Here we have another word problem related to linear equations. I can ride my bike to work in an hour and a half. If I drive 40 miles per hour faster than I bike and it takes me 30 minutes to drive the same distance, how far is it to work? Okay, so here we have a couple of rates, we have times, distance, rate, time problem. Hopefully that formula sounds somewhat familiar. Distance equals rate times time. Okay, so in this particular problem, we're actually dealing with two scenarios. So we're dealing with biking and we're dealing with driving. What comes in handy for people to sort of organize their thoughts is to make a table. Okay, so what we have is distance, rate, and time, bike, and drive. Okay, so in both instances, I am going from my house to work. So what does that tell us about the distance? It tells us that our distance is actually the same. We don't know what it is, but they are equal. Okay, rate. The rate of our bike, we don't know that. But we do know that we drive 40 miles per hour faster than we bike. So let's call our biking speed x. And then our driving speed is just 40 more than that. Okay. And lastly is time. Takes an hour and a half to bike, takes 30 minutes to drive. Careful with our units. Here we're talking in 40 miles per hour, so we're dealing with our units of speed is hours. So we need to make sure we put it in the same way. So time then for biking is hour and a half, 1.5. Time for driving is 0.5. So we now have a table. We have distance, rates, and times for everything. We need to figure out how to piece it all together. The trick is that our distances are the same. So we know that rate times time of our bike is equal to rate times time driving. They're going the same place, has to be the same distance. Okay, so our rate of biking is x. Our time of biking is 1.5. Our rate of driving is x plus 40, and our time driving is 0.5. So from here, we've turned our word problem into a table, into a linear equation we can then solve. Okay? Solving this as we would any other equation, we want to make sure we distribute all our information. So this 0.5 has to go to everything involved. 1.5x, this side stays the same. 0.5x is equal, that's a plus. Plus 20. Getting x's all to one side, subtract 0.5x. 1.5 minus 1/2 is just x is equal to 20. So we have x is equal to 20. Here that relates to the rate of our biking, which isn't what the question asked for. The question is asking for how far is it to work. So I know that my biking speed is 20. We can go back to distance is equal to rate times time. My biking speed is 20. My biking time is an hour and a half. So that biking speed times the time it takes me is going to give me my distance, which is 30 miles. Okay, we could just as easily have taken this biking speed, plugged it back in here. So that tells us my car speed is 60 miles per hour. It takes me half an hour to drive. Half an hour times 60 miles per hour, 30 miles. We get the same answer. So by taking our word problem, making a chart, making an equation, we're able to answer the problem.